Hey guys, Mr. Pouts here. I am working on lesson 21. This is day 1, so 21.1. Um, and we are on page 219 and 220, I believe. 219 and 220 here. Just want to give you some homework help here if you have questions on the practice at all. There are some reminders, some tips at the bottom right corner here. These are actually really helpful. They're a review of some of the things you'll need for this lesson. But make sure you're trying it first. Make sure you're trying these before you actually look at the video, because I want to see that it'll make a lot more sense. It'll help you a lot more if you're putting the effort in first, and then you can see either if you did it right or if you did it wrong, where you went wrong. It's a lot better that way. So numbers 1 through 3 all have to do with this example at the top. It says triangle ABC is a right triangle whose right angle is angle ABC. So that means this is a right angle. Okay, that's what it says right there. ABC would go from A to B to C. So that's that triangle. Here, what I'm going to do is put it like this. Get rid of that. All right. Angle ABC and angle DBF are vertical angles. So vertical angles, we talked about, you've learned these in the past. They're actually down here. It says non-adjacent angles formed by intersecting lines. Vertical angles have the same measure. So essentially they're opposite of each other. So like right here, these two lines form 4 angles, but these two are opposite of each other. So they're actually the same. So I would say that these two together are actually also right, or that would be right angles right there, DBF. So it says, so they have the same measure because measure of angle ABC is 90 degrees. The sum of measure of angle DBE and EBF is also 90 degrees, meaning this whole thing is 90 degrees as well. So we know that this angle, I'm going to put a star in the angles, those two angles have to add up to 90 degrees. And that's why they set it up X, because X is the one angle, and X minus 12 is the other angle. If those two angles make up 90 degrees, they have to add up to 90 degrees. So then when you actually add up the two x's, you get 2x. 2x minus 12 is 90. You can solve it from there by, here would be adding 12 on both sides. Adding 12. You get to 2x equals 102, and you can divide by 2 on both sides. So that'll get you x is 51. So we know that this angle right here, even though it looks like it might be cut directly in half, we know that x is 51 degrees. That would mean that this angle right here is 51 degrees. Okay, whoops. Now, there's actually multiple ways you could figure out angle DBE. So number 1 asks you, what is the measure of angle DBE, and explain how. So one way you could do it is that if you know that x is 51, and if you want to find the measure of angle DBE, so I'm going to put that in blue here now as well, this angle, which is x minus 12, if you know x is 51, let's just plug in 51 for the x. So then the measure of angle DBE would equal 51 minus 12. 51 minus 12, if you check it out, is 39. So 39 degrees. So the measure of angle DBE for number 1 here is 39 degrees. Okay, you just have to explain what you did there. The other way you could do it is, we said at the beginning that this whole thing, these two together would make a right angle. So I could say 90 degrees is a right angle. Let's subtract the 51. Whatever's left over would be my other angle. So I borrow here, I get 8. It's 9, so 39. Get the same answer. Okay. All right, so we know that this one, I'm going to say this angle right here is 39 degrees. So I'm just going to keep labeling everything that we have. Go to number 2. Number 2 says, what is the measure angle GBC? Angle GBC, I'll put it in, let's use purple here. GBC is this one right here, GBC. The measure of angle GBC we're trying to find. Now, if you look at that closely, come on, work for me here. There we go. Measure angle GBC is opposite of this one. That means they're those things called vertical angles, and they're the same. So if we know that DBE was 39, then we know that GBC is also 39 degrees. Okay, so I would say the measure of an angle GBC, I apologize, my computer's going really slow right now. GBC is 39 degrees because we have to explain, it is a vertical angle to angle DBE, so they are the same. All right. You can put that into your own words if you had different words as well. Now it says, explain how to find the measure of angle ABD. Measure of angle ABD. So I'm going to put that in big red. ABD is this one right here. Okay. Now, if the measure of angle ABD, that's what we're trying to find, here's what I would look at. All the things that we've done so far, if we know that these two are 90 degrees, this is 39. The 39 and 51 makes the 90. I have one big long line here. And that's the thing called a linear pair. If you have something broken up, because I also have it going broken here. Meaning this whole thing, a linear pair has to make up 180 degrees. So I'll put a big loop. This whole thing is 180 degrees. And if we know that part of it is already the 39 and 51, then whatever's left would have to add up to 180 degrees. So for number 3, it does ask you to explain. I'm going to show you if I have 180 degrees, and if I subtract the 39 and I subtract the 51, which is the same thing as subtracting 90, I get 90 degrees. Okay, because they all have to add up. They all have to be supplementary. They all have to add up to 180 in that case because they made that line. So explain how, if they all have to add up to 180, you subtract the other 2 and you'll get what's left over. It ends up being 90 degrees. All right, I'm going to go to page 2. One second here. This is really weird. All right, let's go to the back side. Number 4. It says in the diagram, EA and EC are perpendicular. That's what that's referring to. That means that they would make a 90-degree angle. So if this one is perpendicular to this one, they make a 90-degree angle. Okay, so now BD is a straight line. Okay, find the value of x. How do you find it? Well, if we want to find x, there's a couple different things that have x in it. What I would do is, if I know that these two things right here make a 90-degree angle, if I can find this one, then I know that they add up to 90 degrees. If I can find this one, I could also look at these two and know that these two add up to 180 because they make a straight line. So there's 2 different ways you could go about doing it. But I would say that if these are 90 degrees, and this is x, this right here would be whatever that 90 is minus whatever x. So if x is 45, we'd take 90 minus 45 and we get this. If x was 30, we'd take 90 minus 30, and I know that this would be 60 then. So if I have x and I have 90 minus x, those two things add together should add up to be 90 degrees. But that's just going to tell me that they're the same. Well, what I could do with that is I could also say, okay, because that's not going to show anything, the 90 minus x. Let's use that with these two. If I know that the 3x minus 10 and the 90 minus x, those make a straight line. Those have to add up to 180. Then I can solve it for x a different way. And I can look at, okay, I have 3x minus 1x. That gets me 2x. If I have a negative 10 plus 90, that's 80. And then I have a really short equation to solve. I can subtract 80 from both sides. I'm going to bring this up here. I'm left with 2x equals, this canceled out. 180 minus 80 is 100. Divide it by 2. I get 50. So my answer for x is 50. The hardest part there was setting it up. Getting that this part was 90 minus x. But once you do that, you're just using your knowledge of solving equations to get it from there. All right, last thing, 5 and 6 kind of go together. They're all part of this diagram. This is probably the most challenging one on here because there's a lot of parts to it. Number 5 says explain how you'd find angle STO, and then number 6 says actually find the measure of angle STO. So I'm going to find the measure of angle STO and leave the explaining for what we did up to you. So if I want to find the measure of angle STO, that's this one right here, okay? But all that I have is this, and I actually have this one too. What does that refer to? So that's 90 degrees. So that would be my 90 degree angle right there. But what I do notice is that those three, if I look at those three, these three all make a line, and lines are supplementary. It's a linear pair. They add up to 180. So what I'm going to do is I'm going to take those three things, 2x plus 8 plus 90 plus 71 minus x, and those have to add up to 180. Okay? And now once you find that, you can solve it. All right, so let's take the x's. 2x minus x, so that's just 1x, right? And I've got 8 plus 90 is 98 plus 71. Oh, that's a big number. 98 plus 71 would be 169, I think. Oops. And those have to add up to 180. So I can subtract that from both sides. I get 11. Divide both sides by 1, and I get x is 11. Now, you might be asking yourself, we didn't want to find x. We wanted to find the measure of angle STO. So why did we find x? Well, in this case, you have to find x in order to find the measure of angle STO. So, if I know that x is 11, I'll take everything I have here. Let's just put in for right here. 2 times 11 is 22 plus 8 would be 30. So that means this is 30 degrees. And I know that these two also make a line right here. So those two also have to add up to 180. So if I take 180 minus the 30, I get my measure of angle STO. So that's 150 degrees. All right. Now I'm going to leave it up to you to explain what we just did. That's practice for page 219, 220, the beginning of section 21, lesson 21. I hope that helped. I didn't want to overdo it here, but I wanted to give you some guidance if you were stuck on this, since this is the very beginning of this lesson. We're going to be doing more stuff with those types of angles as well. All right, that's it for today.